Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today's discussion will be about isometric projections of frustum of a hexagonal pyramid. So let us go through the statement. So we are required to draw the isometric projections of frustum of a right regular hexagonal pyramid. Side of base of hexagon equal to 30 millimeter. Then side of top hexagon, it is equal to 20 millimeter, and the height of the frustum happens to be 50 millimeter. Since this is a hexagonal pyramid, so this has been cut by a cutting plane parallel to its base. So the remainder solid is called frustum of the hexagonal pyramid. And in this frustum of the hexagonal pyramid, the base edge happens to be 30 millimeter. Then the edge of the top face of the frustum, this is equal to 20 millimeter, and the axis height of the frustum will be 50 millimeter. Now we will be drawing the isometric projections of the frustum of this hexagonal pyramid. Now here you can see this is the top portion of the frustum. This is the bottom portion of the frustum. First of all, we have to draw the top view of this hexagonal pyramid. So when we have to draw the top view, you see the edge of the hexagon of the base. This is the hexagon which lies at the base over there, right? So this hexagonal pyramid is resting on its base on its hexagonal surface over there. Now this hexagon edge will be 30 millimeter. So we are going to make the geometric construction corresponding to this 30 millimeter, that is the edge length will be 1 to 2, and this is the hexagon, that is the outer hexagon which will be obtained, and the points of the hexagon will be 1, 2, 3, 4, 5 and 6. Now we know that this is the upper portion of the frustum. So here the edge of the hexagon will be 20 millimeter. So similarly, once we join all the diagonals of this particular outer hexagon, now what we are going to do, wherever between these two diagonals we are able to find the edge length is equal to 20 millimeter. So there once again another hexagon we have created. So this is our internal hexagon which has been created corresponding to the top face or the frustum of this hexagonal pyramid, right? So we have got now two hexagons over there. So the first hexagon is corresponding to the edge length of 30 millimeter. This is the outer hexagon, 1, 2, 3, 4, 5, 6. Whereas there is another hexagon which is the smaller hexagon. This is the hexagon which has been drawn corresponding to the top face of this frustum of the hexagonal pyramid. Now corresponding to these two hexagons we have drawn the front view as well. So this will be the front view of the frustum corresponding to the outer hexagon, and corresponding to the smaller hexagon, this is the two edges, that is the external most edges we have been able to obtain. Now having obtained these two hexagons, that is a smaller hexagon with edge is equal to 20 millimeter, and the bigger hexagon which is corresponding to the edge which is equal to 30 millimeter. Now we know that we are required to draw the isometric projections of frustum of this hexagonal pyramid, and we cannot transfer this hexagon directly onto the isometric projection. So what we need to do, we have to inscribe both of these hexagons within the rectangular figures over there. So the outer rectangular figure is A, B, C, D over here, right? So this is the outer rectangle. So in the outer rectangle we can check that this is the longer edge of the rectangle, whereas this is the shorter edge of the rectangle. Similarly, corresponding to the smaller hexagon which corresponds to the top surface of this frustum. So second rectangle has also been drawn over here, and the edges of the smaller rectangles are A1, B1, C1 and D1. Now we have got two rectangular figures which are going to inscribe two hexagon surfaces over there, and since into the hexagons there are going to be inclined edges which will be corresponding to the non-isometric line. So these lines cannot be directly represented or transferred onto the isometric projection. So what we need to do, we are going to draw first of all two rectangles, that is the outermost rectangle will be drawn corresponding to the base and the smaller rectangle will be drawn corresponding to the top surface of this particular frustum. And using the rectilinear distances, we will be able to identify and locate all the 6 points of the base hexagon and similarly all the 6 points of the top face of the frustum of this hexagon over there onto the isometric projections. Now let us see how we can proceed while we want to draw the isometric projections of this frustum of the hexagonal pyramid. Now in this case we need to work out the two edges over there. Please see, this is the bigger rectangle corresponding to the base of the hexagon. So here the side AB, which is corresponding to the bigger rectangle, this we have marked as x1, and similarly the width of this bigger rectangle which is corresponding to this hexagon which is drawn with an edge length of 30 millimeter. So this has been marked as y1. So x1 and y1, these are the edges of the rectangle which is the bigger rectangle corresponding to the base. Similarly, corresponding to the inner rectangle which is corresponding to the hexagonal face which is obtained at the top face of the frustum. So the points are A1, B1, C1 and D1. Now A1, B1, that is the longer edge corresponding to the smaller hexagon. So this we have marked as x2. Similarly, the width corresponding to the smaller hexagon, so this we have marked as y2. So x1 and x2, these are the longer edges of the two rectangles. x1 is the rectangle of the base, x2 corresponds to the longer edge of the rectangle at the top. Similarly, y1 is the width of the bigger rectangle which is corresponding to the base, and y2 is the width of the smaller rectangle which corresponds to the frustum portion or the top portion of this hexagonal pyramid. Now we need to work out corresponding to all these dimensions the isometric length. So the first thing we are going to do is about the construction of the isometric scale. So we are going to start this problem with the construction of the isometric scale, in which the true length scale will be drawn at an angle of 45 degree and the isometric length will be drawn at an angle of 30 degree. Then the true length distances will be marked onto the true length scale, and then perpendicular distances will be drawn, projections will be drawn onto the isometric length scale. So all the distances x1, x2, y1, y2 and all other rectilinear distances, they will be first of all transferred onto the true length, and the corresponding isometric lengths will be evaluated while drawing the isometric projection. Now let us start with the construction of the isometric projections. Now this is a case of hexagonal pyramid which is resting on its base, that is the hexagonal base, onto the ground. And what is the edge of the base? Edge of the base happens to be 30 millimeter. And what are the dimensions of these two edges? That is AB, which is equal to x1, and BC, this is equal to y1. So these are the two dimensions, that is x1 and y1 are the two dimensions which we are going to locate along the x-axis and the z-axis respectively. So in order to draw the isometric projections, first of all we have drawn the ground line, that is, this is the horizontal ground line or the datum line. Then we have drawn the isometric axis, that is x-axis at an angle of 30 degree, and we have drawn the z-axis at an angle of 30 degree, and the height of this pyramid will be drawn along the y-axis in this direction, right? But the base we are going to draw first of all. So the rectangle corresponding to the bigger hexagon will be drawn along the xz plane. So let us see how do we draw this. So we are going to mark the longer edge of this rectangle that we have obtained by inscribing this larger hexagon corresponding to the base, which is having the edge length is equal to 30 millimeter, right? So we are going to mark x1 distance along the x-axis, while the y1 distance will be marked along the base in the direction of z-axis over there. So we know that x1 will be located over here, y1 will be located over here. Now we are going to draw two more isometric lines, that is one corresponding to this one and another one will be parallel to the z-axis. So one will be parallel to x-axis and the another one will be parallel to the z-axis. Now let us carry out this procedure. AB. So this is the length of the longer edge of the rectangle, right, which will be lying onto the base. Similarly, BC. So this is the shorter edge of the rectangle which we have marked. Now we are going to join this with two more isometric lines. So line CD, that is the edge CD, it is parallel to the edge AB over here. And similarly, another isometric line has been drawn which corresponds to the edge AD. This is our edge AD of the larger rectangle which corresponds to the base. So now we have obtained all the four edges of the rectangle, and once we draw this rectangle, now the next step is we have to complete the construction of the rectangular prism. That is, we are going to mark the height. So how much is the height of this frustum? The height of this frustum is available with us as 50 millimeter. So this is the height of the frustum over there. Now we have marked this height along the y-axis. So this is the actual y-axis and these are the two isometric lines. So one more isometric line from point D we are going to draw, right? It is this one. So having drawn these three isometric edges corresponding to the height of the frustum, now all these three vertical lengths, they are parallel to the y-axis, which represents the height of this frustum of the pyramid. Now we are going to draw isometric lines parallel to x-axis and parallel to z-axis so that the top face of this frustum of this hexagonal pyramid could be completed. But one thing we must notice over here, that the base corresponds to the bigger hexagon which is having the edge equal to 30 millimeter, whereas in this frustum we have observed that corresponding to the top portion of the frustum we don't have this bigger a rectangle which will be required over here. So the top rectangle corresponds to the size A1 B1 and B1 C1. So A1 B1 we have marked as distance x2, and we can witness from this figure, right, as it is clearly observed from this figure, x1 dimension is bigger than the x2 dimension, and similarly shorter edge of the smaller hexagon, that is y2. So once we obtain this rectangle over here, so then in this rectangle also we are going to get this dimension y2, which is corresponding to the smaller rectangle which is inscribing this smaller hexagon of the frustum top, right? So this y2 is also smaller than y1. But while we have completed the construction of this hexagonal prism, we have observed that the top face is still x1 and y1. So what we have to do, we have to work out the center points corresponding to this. So how the axis can be located or the center of locus can be located, I have to obtain the midpoint of this x1 dimension over here. Similarly, the midpoint of this x1 dimension has been obtained here. So joining these 2 points, one center line has been located. Similarly, the midpoint of the y1 edge has been located here, and the midpoint of the y1 edge has been located over here on the top surface. So the second center line has been located. Now we know that on the top surface we do not have the dimensions as x1 and y1. So on the top surface we have got how much dimensions? Instead of x1 we have the dimension of x2 over here, and x2 is smaller than x1. So what we will be doing? With respect to this center line, I will be marking x2 by 2 on this side, x2 divided by 2 on this side. So the total dimension should become x2 over here. Similarly, the distance y2 divided by 2 will be offset on this side, y2 divided by 2 will be offset through this axis on the other side, so that my dimension on the top side should become y2 over here and x2 over here. So let us do it. So please check, this is my dimension x2. Okay, so this was x1 over here, this dimension will be x2. So we have marked this dimension in such a way that using this center line over here, there will be an offset of x2 divided by 2 on left side and x2 divided by 2 on the right side. Similarly, on the other side, again using this center line, I have marked the distance of this projection line equal to y2 divided by 2. Similarly, the distance of offset on the other side will be y2 divided by 2. So this way I have been able to obtain a smaller rectangle corresponding to the top portion of the frustum of this hexagonal pyramid, and the dimensions of this rectangle, they are x2 over here and y2 over here. So now the two rectangles, they have been obtained over here from the true length. Now the corresponding 6 points of the outer hexagon, they will be located onto the base, and corresponding 6 points of the smaller hexagon, they will be located onto the top. So let us do it. So here we are going to start with once again working out these points. So before we start, we can see the names of the points A1, B1, C1, D1, and we can check if A is lying on this side, so A1 is also lying on the same side. So it is A, B, C, D, and in the top view also you have in the same order A1, B1, C1 and D1 outer rectangular points, they are being marked over here. Now let us work out the points of the hexagon on the base. So I know the distance between A and 1, it will be equal to distance between 2 and B. This will also be equal to distance between 4 and C. This will also be equal to distance between 5 and D. So you measure only one distance, so automatically the 4 points, that is D5, 4C, 2B and 1A will be located. So please see, I have marked these points A1, B2, similarly C4 and D5. So these 4 points, they have been marked along AB and along CD over here. So 1 and 2 points, they have been marked along AB, and 4 and 5 points, they have been marked along CD. Now let us mark the other 2 points. So please check, other 2 points, they are B and 3. So we'll measure this distance B and 3 on the true scale, converted to isometric scale, and B3 distance will be equal to A6. So B3 distance, it is equal to the distance of A6. So similarly, we have marked the isometric lengths B3 over here and A6 over here, right? So all the 6 points of the base, they have been evaluated. Similarly, all the 6 points of the top face of the frustum will be evaluated. Now let us see, distance between A1 and this point will be 1, 1. Right, so A1 and 1, 1, this distance, this will be equal to B1 and 2, 1. This will also be equal to the distance C1 and 4, 1 and D1 and 5, 1. So please see these distances A1, 1, 1, B1, 2, 1, C1, 4, 1 and D1, 5, 1. So we haven't marked these points because these points are on the same locus line, right? So if this is 5, this point will be 5, 1. If this is 4, this point name is 4, 1. If this is 3, name of this point is 3, 1 over here. Similarly, B1 to 3, 1 point and A1 to 6, 1 point. Please check, this is B1, this will be 3, 1. So this distance is equal to A1 to 6, 1 distance. So all these points of the top face, they have also been located corresponding to the hexagon at the top face of this frustum. Now, when the observer is going to look at this solid from this direction, so all the edges of the top face, they will be visible to the observer. So we are going to join 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1 and 1, 1 dark, right? So they will be joined by using the object lines over there. Okay, so thick lines will be used over there, solid line. Now the vertical edges, we can see what are the vertical edges which are visible. Please check, 1, 1 and 1 is visible, 2, 1 and 2 is visible, 3, 1 and 3 is visible. Similarly, 4, 1 and 4 is visible. So these are the 4 edges which are vertical ones which are visible, but 5, 1 and 5, they are not visible. Similarly, 6, 1 and 6, they are lying behind, so they will not be visible. On the same lines, these 3 edges of the base, 4, 5, 5, 6 and 6, 1, they are lying behind, so they are not visible. They will be joined by using construction line. And the edges 1, 2, 2, 3 and 3, 4, they are lying in the front side. So these 3 edges of the base of the hexagon, they will be visible, right? So 4 vertical slant edges, they are visible, so we have joined them dark, whereas 2 slant edges over here, so these are the slant edges 5 and 5, 1, 6 and 6, 1. So these 2 slant edges of this pyramid, they are not visible, so we have not drawn them dotted, but we have just joined them with the help of a construction line, so that we can have the complete feel about the total construction of this frustum over there, right? Even if we have omitted these points, edges over here, I can omit this edge, I can omit this edge, I can omit this edge, or even this edge and even this edge. Still the construction of this hexagonal pyramid would be complete over there. So this is the construction of frustum of a hexagonal pyramid, in which at the top surface you have a smaller hexagon, at the bottom surface you have a bigger hexagon, and the height of this particular frustum has been marked as 50 millimeter, right? So this is the way you can proceed in order to complete the construction of the frustum of a hexagonal pyramid, right? So this is all for today. So we will be continuing with few more cases of the isometric projections of similar solids in the coming lectures. So thanks a lot. Thank you very much.